Hey everyone, hope you're doing well. Hope you had some success last day with 8.1, the sine law. Before we get going on the cosine law, some of you have been asking some questions or emailing me asking about are we going to have any tests? And the answer is at this point, no, we're not going to have any tests. I'm going to try to give you some opportunity coming up to demonstrate that you understand some of this material. And obviously you've been doing your homework, or I hope you have, and you're wondering yourself whether you're understanding the material or not. So I'll give you some opportunities to do that at a later date. At this point, as we mentioned before March break, even in class, grade 10, these marks don't really matter for anything. They don't go off to universities, they don't go off to colleges. They're just for your own use. Don't worry about marks. Worry about just trying to learn as much math as you can, understand the math, all this math that we're doing right now, trigonometry, and another couple of weeks time, or another week and a half, 2 weeks time, I guess, we'll be getting into quadratics. It's all used in grade 11 math and physics. So you just want to make sure that you understand it. Don't be sweating the marks at this point. All right, so the cosine law. We use the cosine law when we can't use the sine law. There's times that the sine law just doesn't work. So the example I give you here is the tunnels will be built through a hill to connect points A and B. Point C is chosen to be visible from both points A and B, and the following measurements are taken. So if we graphically represent this data here, actually let me redo that. So we have a hill, and we want to build from point A here to point B. We want to build a tunnel through. Now we can't see from A to B. We can't take a measurement over top of the hill. Obviously, that's a longer distance than from A to B. So how do we do this? So point C up here is chosen, and point C is chosen because it has a great view of A, and it has a great view of B, and this is the distance that we want to find. Now we do have some information given. We do know that angle C here is 67.5 degrees. Across from angle C is side C, and that's what we want to find the length of. Angle B, we don't know what that angle is, but we do know that from C to B here, this length here, so this is actually side A, is 5.18 kilometers. And we know that from point C to point A is 3.65 kilometers. And of course, that would be side B. So here's the issue. If we try to use our sine rule from last day, B over, let's say, sine B is equal to A over sine A. If we were to fill this information in, we know that B is 3.65, and we don't know sine B. We know A is 5.18, but we don't know sine A. And I told you last day we needed 3 pieces of information to find the fourth, and we only have 2 pieces here, so we cannot solve this. And even if we factor in C, so C over sine C. In this case, we don't know what the length of C is. That's what we want to find out. And we know this is sine 67.5. We still don't have the 3 needed pieces of information. So if we look just at this ratio here, we only have 2 out of the 4. We've already talked about this ratio. We only have 2 of the 4. And if we even look at this ratio and this ratio, we have 2 out of the 4. So we can't solve this using our sine law. So hence, we're going to use the cosine law. So let me introduce that to you. So the cosine law, and it says for triangle ABC, which not a right triangle, it's an acute triangle. It gives us the cosine law, there's 3 different variations of it depending on what we want to try to solve. So if we are trying to solve side C, opposite angle C, we would use the cosine law, and it would be this version of it. So because it's c that we want to solve, c squared is equal to a squared plus b squared minus 2ab cosine c. That's it. Not going to try to explain it to you. I'll end up just confusing you. At this point in grade 10 math, all you have to do is know how to use it. And likewise, if I wanted to find point A here, opposite angle A, I would use a rearranged version of this. And we get b squared plus c squared minus 2bc cosine A. And if it was side B that we're trying to find, it would be b squared equals a squared plus c squared minus 2ac cosine b. So 3 versions of the same law. You use whichever one you want. And when do we use cosine law? We use it to find the third side of a triangle when two sides and a contained angle are given. And what is a contained angle? This is an angle between two given sides of a triangle. So if you remember back to the question that we were presented a moment ago, we have two given sides. We want to find the third side. And we also have a contained angle. And in this case, C is our contained angle between the two sides that are given. So let's go back, and now that we know the sine law, let's go back and solve this for the original question. So since it is side C that we want to solve, we use that version of our cosine law. So c squared equals a squared plus b squared minus 2ab cosine c. Let's plug in our information that we have and simplify. So c squared is equal to 5.18 squared. That's the length of side A, plus 3.65 squared minus 2 times 5.18 times 3.65 cosine 67.5. Starting to simplify, 5.18 squared is 26.8324. 3.65 squared is 13.3225. And cosine 67.5, rounded to 4 decimal places, times 3.65 times 5.18 times 2, or negative 2, however you want to do that, is going to lead to a subtraction of 14.47. Continuing to simplify, putting these three together, we get 25.68, and that's c squared. We don't want c squared, we want c. So c would be the root of 25.68. C would be 5.07. So that tunnel through the mountain, this tunnel right here, is 5.07 kilometers long. All right, let's try another example, and then we are done. So, triangle KLM. And of course, the side opposite angle L is side L. The side opposite angle M is side M, and the side opposite angle K is side K. And we're told that side K is 8 centimeters long, and we know that Side M is 5 centimeters long, and we're told that angle L is 70 degrees. So we can't use our sine law here because we don't have a pair of information. We don't have both angle L and side L, or angle K and side K, or angle M and side M. So sine law is off the table. We do have two sides, and we know the angle in between them, the contained angle. We do have that, so we're going to use our cosine law. So the first thing we'll do here is let's find L. Let's find this length. So we'll use our cosine law for L, and that's going to be L squared is equal to M squared plus K squared minus 2MK cosine L. So just substituting the letters A, B, and C for the ones that we have in this triangle. Putting in what we know. M is 5 squared, 8 squared minus 2, 5, 8. And cosine L, which is cosine 70, is 0.3420. Simplifying, 5 squared is 25, 8 squared is 64, and this times this times this times this is 27.3616. Continuing to simplify, putting these three together, we get 61.6384. That's for L squared. We want L, so we'll take the root of that. And we discover that L is 7.9 centimeters long. Perfect. We have three sides. If we're going to solve this triangle, and remember, solving a triangle is finding all sides and all angles, we need to find two more angles. Let's find angle K. Now, in this case, we have our pair of information. We have angle L and side L. And we have half of that. So now we can actually go back and use our sine law because we do have a pair of information. So to find angle K, let's use our sine law. So sine K over K is sine L over L. So sine K, we know that K is 8. And we have sine 70 from there over 7.9. Cross multiplying, 7.9 sine K is equal to 8 times sine 70. Divide both sides through by 7.9, and we get sine K on its own over here. 8 sine 70 is 0.9397, and that's all over 7.9. Continuing to solve, sine K, 8 times 0.9397 is 7.5175, and that's all divided by 7.9. Sine K is equal to 0.9515. When we divide that up, to get K, we'd use the inverse function of sine. And K is 72 degrees. So we can plug that in there. To solve a triangle, we need one more piece of information here, and that's angle M. We're not going to use the sine law. We're not going to use the cosine. We're going to keep it simple. We know that there's 180 interior degrees in a triangle. So to get angle M, we will do 180 minus 70 degrees, minus 72 degrees, 70 and 72 taken from there, and we are left with 38 degrees. So that is 38 degrees. So ladies and gentlemen, that's all there is to this. It's just becoming familiar with the formula, how to sub in the values that you have, and simplifying it. So give that a go and good luck.